7 or 8? Okay. So this is going to be 7 from 6-5 homework. Okay, so from 1990 to 2010, the number in millions of females, F, and males, M, employees from the ages 16 to 19 in the United States can be modeled by each of those functions. So F of T is negative 0.007 T squared plus 0.10 T plus 3.7. Yep. And then M of T 0.0001 T cubed minus 0.009 T squared plus 0.11 T plus 3.7. Okay. Where T is the years since 1990. So if T is 1, what year am I in? T is years since 1990. I'd be in 1991. So if I was T equals 5, I'd be in 1995. Okay. The function F is designating the number of females. The function M is designating the number of males based on the year, the modeling data. I need to find M plus F of T. So remember, if I want to find M plus F of T, I need to take M of T and add to it F of T. Yeah, and actually those are interchangeable. So it says in the homework F plus M. It'll be the same because addition I can work either direction. Okay, but yes, technically F plus M. Okay, so I'm going to take the two functions and I'm going to add them together. This is M, and now I'm going to add F. Okay, and so when I add these together, you have to understand what parts can and cannot be added together. For example, T cubes can only add with other T cubes, and there are no other ones. So I know that M plus F of T is 0.0001 T cubed. Okay, and then I need to combine this T squared with that T squared. Negative 0.009 plus negative 0.007, get negative 0.016. And then just regular T's, 0.10 T and 0.11 T, 0.21 T, and then 3.7, 3.7, 7.4. So this is the function here, M plus F of T. So algebraically, all I'm doing is I just literally will add the two functions together, combine the terms that are alike, essentially. Okay. Questions about part A? Class. Okay. Questions about part A? What's part B asking? It's asking to explain what M plus F of T means. So if F is the number of females, M is the number of males, F plus T is the what? M plus F would literally just represent the number of males and females together. That would be 7. Do I have any other questions that I should go over? Yeah. Yeah, 5. 5 also on 6.5. Okay, it looks like fog, but it's not. What is this at? How would I actually say this? F of G or F composed of G. And when it says F composed of G or F of G, okay, that means I'm going to take the function F, and everywhere I see an X, I'm going to replace it with whatever the function G is called or defined as. So here, if I want to do it for this one here, I'm going to write F of X to X to the 3rd power. But everywhere I see an X, I'm going to write what the function G of X is. The function G of X is 3 times the cube root of X. So wherever there's an X and F, I'm going to write this thing here. All right. Do I have any questions? This was a test question. You probably be at about a 2 of your 4, right? You kind of understand a little bit, like you know what to plug in, where, you just don't know how to simplify. Okay. So here, then I would have 2 times, well, this cube is going to apply to both parts here. So I'm going to have 3 cubed. And what happens when I have cube the cube root of X? It cancels out, so what's left over? Yep, an X. Okay, now it's not 3X, it's going to be 3 to the 3rd power because that 3 out there will also get this exponent here. Okay, then 2 is 2, obviously. 3 cubed is 27. And then 2 times 27 is 54. And this is F composed of G. Okay, make sure you understand how it's written. If it's F composed of G, you're going to take G and plug it into F. If it's G composed of F, you're going to take F and put it into G. All right. Anything else? We can do one more. Okay. Let's get to today's lesson then. All right, today we're going to talk about inverse functions. When we have inverse functions, okay, well, first off, well, one learning target, find and verify nonlinear inverse functions. We're probably going to find more than we'll verify. I'll talk about how to verify, but I probably will not be asking you to do that on your assessment whenever we get there. Okay, so before we actually do that, let's just kind of start to understand what an inverse function is. And we can start that by looking at number 1. Okay, so here I have the function named f, and it's equal to 2x plus 3. So what I'm going to do is, since f of x just functions as a y value, I'm just going to rewrite this as the y value. All right. And what I'm actually going to do is I'm going to solve for x. Okay. I'm going to solve for x. So if I wanted to solve for x here, I would have to minus 3. And then what would I have to do to get the x by itself or solve for it? Divide by 2. Nothing too bad. So I would get y is equal to 3 divide y minus 3 divided by 2 is equal to x. Okay. So I want to find the input when the output is 7. Remember, inputs are x values and outputs are y values. Okay. So if my output is a y value, so that means y equals -7. I can actually plug that into here and solve. So I'm going to actually do that and get -7 minus 3 all divided by 2 is equal to x. Because y would equal -7 in this situation. -7 minus 3 is -10. -10 over 2 is -5. So what have we done essentially? Well, we found what y is equal to, and when I find y, it gives me x. If I plugged x into the original equation, what would be the y value I would get out? So this is my output, y. When I plug my y output in, I got my x value. But what would happen if I plug my x value -5 into the original equation? I would get my y of -7. Okay, so this is what inverse functions basically do. You plug in the input into one equation and you get an output. And then if you take that output and plug it into the inverse equation, you'll get the original input. They go back and forth from each other. All right, so I think I'm going to skip over A so we can just get through the concepts faster and actually talk about the inverse functions and exactly how you're going to do that. But we can do the exact same thing here. How would I solve for x here in this situation? How would I get the x all by itself? I will have to square root at some point, but I think we want to divide by 2 first. Let this focus in a little bit. Okay, there we go. So then I get y divided by 2 is equal to x squared. Now I would square root, right? And I would get the square root of y over 2 is equal to x. Okay. So we could do the same thing. I could plug in the output y value 2. I could plug it in here. But 2 divided by 2 is 1. And then the square root of 1 is 1. Okay. I could plug in my y value to get my x value. And then I could take that x value and plug it into the original equation and then get the y value. Okay. Now I can do that. That's how you verify these functions, but it's unnecessary. Okay. So what I'm going to do is I'm going to take this example, unless I have any questions about the relationship between putting my y into this one to get my x and putting my x into this one to get the y. Do I have any questions about that and kind of the flip-flop backwards nature of it? All right, so I'm gonna show you if my original function is this is what my inverse function is. That is the inverse function right there. It's basically the same thing, except for it's all x's. Okay. And how would you read this? This thing looks different. It's a different notation. Okay, it looks, that -1 might look like it's an exponent, but really it's just a notational thing that just says, that identifies this as a function that is specifically the inverse of the original h function. So you would just say that this is the inverse function of h. Okay, and these functions are inverses of each other. And some simple examples to me makes a lot of sense. I plug in x and I square it, and then I divide by, and then I multiply by 2. And this one, I take my x, and then I divide by 2, and then I square root it. All of those math function operations go in reverse and are also the inverse operation, right? Square rooting is undone by squaring, multiplying is undone by dividing. So they're literal reverses of each other. As I know all of you are, your big spreadsheet people, love a good old Google Sheets. You would use this a lot for that stuff. So, okay, let's actually go and find some inverse functions. Okay. There is a relationship between the graph of an original and an inverse function. And instead of graphing all of them, I think I'm just going to show you on the calculator, and that's kind of the most we'll do with it. Okay. But then after we do 3, we're probably just going to jump to the last page, and I'm going to show you some more complicated ones, just so we can get you going in work time and talk about what the rest of the week looks like. Okay. This is how you're going to do. This is how you're going to find that inverse function. Essentially, you are going to set it equal to y. I'm going to set it equal to y. Okay, and then actually what you're going to do is, since you want your inverse function to have a variable x, you're going to flip in your way around. And then you solve for y. So I'm going to solve for y here. Side +1 to get x + 1. And then divide by 3. So then here I get y is equal to x + 1 divided by 3. Again, to me, this makes a lot of sense. Inverse of minusing 1 is plusing 1. Inverse of multiplying by 3 is dividing by 3. Based on the way it's written, you would do it in complete reverse order of each other, which inverse. So we have our inverse function. So we have to write it in function notation. The inverse of f, the inverse function of f, is equal to x + 1 divided by 3. Do I have any questions about finding it? Okay, this is how you can verify. You can take whatever x value you want. Anybody have a random x value? Doesn't matter, just somebody pick an x value. 7. I can take 7 and plug it into the original equation. 3 times 7 minus 1. And I'm going to get 20. So what does this mean? I can take my 20, plug it into my inverse function, and I should get what? 7. I should, okay? So I'm going to go 20 + 1 and divide by 3, and I get 7. That's how you can verify it. I'm not going to ask for you to verify, but you can pick literally whatever x value you want, plug it into the function, get a y value, take that y value, plug it into your inverse function, you should get the original x. Okay. When you see the graphs of these, nice little callback to geometry, which I know everybody's reminiscing of the days of last year's geometry. You can graph each of these, and if you recall what a reflection is, okay, the line will actually be a reflection of the other, or curve will be a reflection of the other through the y = x line. So if there's a line y = x, the lines are reflections of each other. Okay. Normally, we would have you mark each of these down, but ultimately, I think we're just ready to get so. The big thing you need to know is you don't have to be able to do this. You don't have to verify if you don't want to. Although it's allowing you to check your work, you just have to be able to write me the inverse function. Okay. Let's look at a problem like 5, and then we're going to change 6. We'll actually do 6 on the back page, and then we'll be done. Pretty short lesson. All right. If I want to find the inverse function of f, if f is defined as 2x to the 3rd power plus 1, I need to replace the f of x with a y. And then I need to flip it, the x and the y, so I can solve for y. Okay, what's the first thing I'm going to do to solve for y here? Subtract 1. Now what am I going to do? Divide by 2. And what's the last thing I have to do? Cube root, right? This is like the major concept through this whole chapter is understanding the inverse relationship between cube roots and cubing, 4th power, 1/4 exponents, and the radical equivalencies. Okay, so then I'm left with y is equal to the cube root of x minus 1 divided by 2, which means that that is my inverse function. So now I just have to write it in function notation. The inverse function of f is equal to the cube root of x minus 1 all divided by 2. And that's it. Okay. Do I have any questions about a problem like that? Because what I'm going to do is I'm going to ramp up the difficulty here a little bit. Okay, and we're actually going to do it on the back page where there's a little bit of space. So we're just going to cross out that 7, and we're going to make our own new problem here. Okay, so this one is f of x is equal to 1/3 times the square root of x plus 2 minus 4. And I have to find, again, this is notation for inverse function of x. Okay. Process is the same. And what's the first thing I need to do? Okay. The one thing I've always kind of wondered, but we'll always teach you like, oh, have it equal to y. Technically, you could just flip f of x and y together, but then it just has an f in there and it looks funky. And then once I do that, what can I do now? Okay, flip that x and y. And now I can start to do what? Solve for the y here. Okay, and what's the first thing I can do for that, right? We have an idea. Add 4 is definitely going to be a good start. So now I'm left with x plus 4 is equal to 1/3 the square root of y plus 2. Now notice this isn't like an exponent or telling me the root. That's 1/3 times the square root of y plus 2. So what can I do now? Timesing by 3. Remember, multiplying by 1/3 is the same as dividing by 3. So I can undo this just by taking the whole thing and timesing it by 3. And that will undo this 1/3. So if it was 1/2, I would times by 2. Okay, so then 3x plus 12 is equal to the square root of y plus 2. And then I would do what? Okay, so here I have a square root by itself, right? So I need to undo the square root so I can minus 2 get the y by itself. So yes, I'm going to take this to the second power. That will be the inverse operation of my square root. How do I do this? How do I do 3x plus 12 squared? Box method. Now there are other methods, and if you know how to use them, I encourage you to. For me, in general, I just do the box method, give you all some consistency. There are shortcuts for this one, but I'm not even sure. I'd have to think. A squared. So, okay, anyway, 3x times 3x would give me what? 9x squared. 3x times 12. And then we're gonna get the same thing down here. And then what am I gonna get here? So the left side is now equal to 9x squared plus 36x plus 36x. So I can write 72x instead. And on the right side, my square root is now been undone or canceled out with my squaring, because squaring undoes square rooting, and vice versa. And subtract 2, and I'm basically done. So I'm going to finish this over here. So now I have y is equal to 9x squared plus 72x plus 142, which means that is my inverse function. Okay. I think I'm going to verify this one because it requires a little bit more work, just to double check for myself. 1/3 times the square root. I'm going to pick x to be 7. And I get -3. So when I plug in -3 here, what should I get? I should get 7. I really hope I get 7, because then I have to go back. 72 times -3 plus 142. Nice. And that's how those inverse functions work. And you can verify it. Technically, you can pick a random x value. Just so. Okay, do we need another problem like this for you all to try? Or do we just want to dive into the homework and stuff? One more? We'll do that in the area G below. And we're going to say g of x is equal to 1/2 times x minus 5, and then -1, and we want to find the inverse function of g. Notice that just because this one's g of x, everything you do is the same. It's just or the function is just named g. Okay. You guys want to work on that on your own? Let me walk around and see how you're doing. Okay, I'll do that.